Alright, so it's a little bit jumbled because I copied this into a different program, but today is Thursday. In class, you're going to complete number 13. You had left the worksheet and the multiple choice questions. You have your quiz tomorrow, which is an individual quiz. And I'm going to start off with a video on the last two examples from the 4.4.2 notes. So at this point, if you really feel comfortable with optimization, you can start your homework. Otherwise, you can watch the video, and it's posted already in Edmodo and YouTube if you want to play it again. So let's start with the first question. Oopsie, didn't mean to do that. So here's the first question I have for you, which is a rectangular page is to contain 24 inches of square print. The margins in the top and bottom have to be 1.5 inches. The left and right have to be an inch. What dimensions should the page be so that I use the least amount of paper? So let's see. So the print, let's see, what am I doing? Let's start with our question. The question is least amount of paper. Paper is something you can touch, so I'm going to minimize an area. And the area would be base times height, or let's see. In this case, they actually gave you your variables. Remember, you have to be able to draw your own picture and label your own variables. Starting off, the area would be how far across the paper is. And I'll write it down here. This is y plus 2, because I got an inch on each side. And this way is x plus 3, because 1.5 plus 1.5. So I get x plus 3 times y plus 2. Problem is I have another variable, so let's go off to the side right here and let's look at what else we have. So they gave us 24 square inches of print. The print's area would be x times y, and that area is 24. Therefore I can solve for a variable. I'm going to solve for y because I like having x in my equation. I'm sorry if this is making you dizzy. It's making me dizzy. Alright. So the area is equal to x plus 3 times y, which is 24 over x, plus 2. I'm going to choose to multiply this out so I don't have to do a product rule. So I get, this would be 24. This would be 2x. This would be 72 over x. And the last value would be 6. So let's clean that up a little bit more. And I get 2x plus 72x to the negative 1 power plus 30. And remember, I'm doing this because it's going to be easier to take a derivative. And remember, we only simplify if we're going to take the function, set it equal to 0, set it equal to undefined. So my derivative becomes much easier. And let's clean that up. Because now I'm going to set my derivative equal to 0, which is why I am now definitely going to rewrite this and create a common denominator of x squared. And then I'm going to set this equal to 0 and a prime equal to undefined. Undefined is the easier one, so I'll do that real quick. And that should make sense. We're not going to use 0 as an answer, but 2x squared minus 72 is equal to 0. X squared is equal to 36, so x is equal to plus or minus 6. A prime, we're going to start at 0, undefined, and we're not going to use 0. See? Then the 6. I'm not using the negative 6 because it's not in my real life domain. And my derivative simplified is right here. So put in 1 and you'll get negative. Remember, I'm ignoring the denominator because it's the whole thing squared. I put in 1,000,000, that would be positive. This is my minimum. What should the dimensions of the page be? So be really careful. The dimensions of the page are x plus 3 and y plus 2. So x plus 3, if x is 6, we get 9. And then if y plus 2, remember up here, If x is 6, then y is 4. Therefore, 4 plus 2 makes 6, so the dimensions of the page are 9. Let's see, inches, it looks like, and 6 inches. Alright, and then the next problem. A builder intends to construct a storage shed having a volume of 900, a flat roof, and a rectangular base whose width is 3/4 the length. The cost per square foot of the materials is $4 for the floor, blah, blah, blah. What dimensions will minimize the cost? So I want to minimize cost. I need a cost function. So I saw some cost here. The cost of square foot for the materials of the floor. And so 4 for the floor, the area of the floor, plus $6 for the sides. Remember, there's 4 sides, plus $3 for the roof. So there's my function, which has absolutely nothing in it right now, but let's take a look. I'm not the best at drawing these diagrams, but you know who is? Mr. Ish. For some reason, a man can draw amazing diagrams. Alright, so, oh, that's horrible. Try to fix that. Alright. So, we can call these length, width, height. X, Y, Z, I don't care. Let's call it length, width, height. So let me start off with just at least writing the areas of the area of the floor would be LW. The sides are a little bit different. It's not a square base, it's a rectangular base, so I would have 2 sides that are the same and then 2 other sides that are the same. So 6 times, let's do the front and the back. So the front would be L times H. The sides would be W times H, and there's 2 of those. And then the roof is the same as the floor, L times W. We still have 3 variables, so I got to use everything else I see. So, whose width is 3/4 of the length. So W is equal to 3/4 L. So let's try to put that in. Okay. What else? There's the 900 feet cubed, which was the volume, so I'm going to write the volume. Sorry, guys. It's not liking me right now. So 900 is the volume, length, width, height. I already have this, so I'm going to actually substitute that in. Oh, shoot. I just realized there's a very good chance you can't see some of this. So, let me come over here. So I'm going to have to insert a different color so that you can see it. I just realized I'm off the recording screen. So, the extra information that we had was that the W was 3/4 of the L. We also got that the volume, you'll hear me freak out soon. Alright, the volume is length, width, height, that the volume is 900, length, width, and height. And since we already got W in terms of L, then I'm going to actually solve for H, because that's the extra letter that's in there, or the extra variable. So let's multiply the 900 by 4/3. I will get rid of this, and then we're going to divide it by L squared. And we get 300, so 1200 over L squared is equal to H. So I'm going to actually substitute this all back into this horrific looking thing. It looks pretty bad, but it's going to look much better in a moment. Let's see. So let's first clean up what we had already. So C is equal to 3L squared plus 12LH plus 9LH plus 9 over 4L squared. And we can still clean this up a little bit, which will help us. So I'm going to add 3 plus 9/4. So that'd be 12. So that's 21/4 times L squared plus 21LH. And then I'm going to put this H in. Times 1200 divided by L squared. Alright, which gives us 21 over 4 L squared plus 21 times 1200 all over L. Yep, I am going to leave it like that for now. So let's see. Pretty long process, I understand that, but let's see if we can make this work out a little bit nicer. So far I haven't taken a derivative. All I did was eliminate variables. Now, I'm going to take a derivative. 21 over 2L plus, so this is L to the negative 1 power, so I'm actually going to turn this into negative. There's a reason I haven't multiplied these numbers out. I just don't feel like it at the moment. Alright, so this is 21L over 2 minus 21 times 1200 over L squared. So we're going to multiply this one by L squared and this one by 2. Over L squared times 2. Set that equal to 0. Set C. Did I forget to write prime? I think I did. Set C prime equal to undefined. Undefined would happen when L is equal to 0. C prime equal to 0 happens when we get this. So I just took the numerator equal to 0, moved the term over. So let's try to clean this up. Divide by 3, and we get that. Which, I guess at that point I can find L cubed is equal to 164,000 over 7, and L is equal to the cube root of 164. You know, there's really a good chance that I made a little mistake somewhere, and if I did, go ahead and Edmodo me. The number doesn't look familiar, but I can't figure out where the mistake is at the moment. I just want to get this done for you. Alright, so we have an L. Let's go look and see what the question was. What dimensions? So I have my L. Remember, W is here. So W is equal to 3/4 L. So I'm literally going to make this look awesome. 3/4 of L. So whatever mistake I made, if this is not the exact value, I apologize. And then my H is right here. Oh, that one's going to be pretty. H is equal to 1200 over L, I think, squared. Yep. Well, that's beautiful. So dividing by L squared is the same thing as multiplying by its reciprocal. So 7 over 16400 to the 2/3 power. How did I get that? I took this thing, which is 1/3 power, and then I flipped it, and then squared it. So the units, I believe, were, let's go back up, feet. So there are my feet. Feet. So feet here, and feet here. I think the one thing I forgot to do, which I think I did that in another video, was I forgot to make an actual sign chart. I'll do that here. This is the cube root of 16400 over 7. That's a 0, so pick 1. 1 would be my value. C prime is, the most simplified form is here. So if I put in 1, it would be negative. Put in a million, and it would be positive. So this is definitely the minimum. There you go. There is the second example. Sorry that it looks bad, but it really is not difficult. It's just tedious. You want to look at how I started the problem. I started it with the question. All that information is really intimidating. You want to focus on the question and kind of place everything else into what you're looking for. All right, there you go.